friends, in this video we will study about the operational modes of 8259 Programmable Interrupt Controller, which is also known as PIC. So let's start with our topic. There are various modes of operations of the 8259 Programmable Interrupt Controller PIC, and these modes of operation, they can be programmed by setting or resetting the command words, that is the initialization command words and the operational command words of the 8259 IC. Okay. So now in this video we will study about the various operating modes. Let us see that what are the operational modes of 8259. There are 11 modes of operation of this 8259, whose names are fully nested mode, end of interrupt mode, So there are 11 modes of operations of the 8259 IC. First is fully nested mode, then end of interrupt mode, which is also EOI, end of interrupt, then automatic end of interrupt mode, which is known as AEOI mode. Then we have automatic rotation, specific rotation, special mask mode, edge and level triggered mode, pole command, and special fully nested mode, buffered mode, and cascade mode. So these are the 11 operating modes of the 8259 Programmable Interrupt Controller. We know that the function of this interrupt controller is to receive the request from the various interrupting devices, and these interrupt requests, they are then sent to the microprocessor. Now the 8259, it is capable of accepting 8 interrupt requests at a time, so which are represented as IR0 to IR7, that is interrupt request from 0 to interrupt request till 7. So these are the 8 interrupt requests which are accepted by the 8259 IC, and then these requests, according to that which interrupt request is currently active, then an interrupt signal is sent to the microprocessor. Okay, so these various operating modes, they decides that in which mode the this 8259 IC is going to work, and these operating modes, they can be selected by setting or resetting the bits of the command words, the initialization command words and the operational command words. Okay, that is ICW or OCW. Okay, so let us study these operating modes of 8259 one by one. First we will start with the fully nested mode. Fully nested mode, it is the default mode of operation of 8259. The 8259, it is getting request from 8 interrupting devices. So the respective corresponding interrupt request will be active at that time. Like from IR0 to IR7, we have the 8 interrupt request. And suppose the fourth interrupting device, it is sending the request, okay, or it is sending an interrupt to the microprocessor. So IR3 will be active at that time, okay, and then this IR3 will be accepted by 8259. 8259 will generate the INT interrupt signal and then send it to the microprocessor. Microprocessor, in response to this interrupt request, it will send an INTA, that is interrupt acknowledge signal, that it has received the interrupt request. And when this INTA signal it reaches to the 8259, then the interrupting device, it will send the interrupt vector address, the address where the service routine or the subroutine is written. Then microprocessor, it is going to execute that subroutine, and then the corresponding bit of the interrupt request, it becomes 0. Okay, so again it is reset. So it is just the default mode of operation in which the 8259 it works. Okay, so let's write the features of this fully nested mode. So this fully nested mode, it is the default mode of operation. In this mode, because the 8259, it can accept 8 interrupt requests, IR0 to IR7. So in this, the priority have to be decided, because suppose if 2 or 3 interrupt requests, they are simultaneously occurring at a time. So which request has to be first acknowledged? So it is decided by setting the priority of the interrupts. So in this mode, the IR0, it is assigned the highest priority and IR7 is assigned the lowest priority. So when the interrupt request, it is noticed by the 8259, the highest priority request, if there are 2 or 3 interrupt requests, then the interrupt request which is having the highest priority, that will be first acknowledged. So highest priority request, it is determined, and the vector address associated with that interrupt request, it is placed on the data bus. So the service routine which is written at this vector address, that service routine will be executed by the microprocessor. Now how the microprocessor, it is going to be informed, or the 8259, it is going to be informed that the service routine has been completely executed. That is done by the end of interrupt command. Okay, that end of interrupt command, it is either given externally to the 8259 or it is automatically set up in the 8259 operating modes. Okay, so that through these commands, the 8259, it get to know that the service routine has been completely executed and this interrupt request has been completely acknowledged by the microprocessor. So again, it is going to check that whether still there any interrupt request is available, or if it is the highest priority, 2-3 interrupts are there, then it is going to execute the second interrupt request. Okay, so here we can say that because the vector address, it is placed on the data bus, so the corresponding ISR bit means the in service register bit. Okay, so the corresponding ISR bit is set. So when this interrupt request is noticed and the vector address is placed on the data bus, so at that time the ISR bit is set. Suppose that the interrupt request 4th is generated and this vector address has been placed on the data bus, so the corresponding ISR bit means IS4, it will be set, it is equal to 1. This is also 1. Now this IS4 bit, it will remain set until and unless the microprocessor it is going to issue the end of interrupt command or the automatic end of interrupt command bit is set. This bit it is available in the initialization command words. Okay, so through the command words this bit can be set. So if it is set, then only this bit will be reset. Okay, in service register bit will be reset. Now when the interrupts are given, like suppose 2 or 3 interrupts are given and the highest priority interrupt has been given to the microprocessor. Now in between the processing, if any of the interrupt which is having more higher priority than the interrupt which was currently acknowledged, then the microprocessor it is going to first acknowledge the highest priority interrupt and then it will acknowledge the lower priority interrupts. So if this in-service register bit it is set, then all the same or the lower priority interrupts, means interrupts which are having the same priority or the lower priority, they will be inhibited, but the interrupts which are having higher priority, they will generate the request and they will be executed. So these priorities of the interrupts, they can be changed according to the programming bits by the bits in the initialization and the operation command words also. So in between the execution of the interrupts also the priorities can be changed. So the priorities of the interrupts, it can be changed by programming the rotating priority mode. So by setting this mode also, we can change the priority of the modes in between the execution also. So this is the fully nested mode. Now let us come to the second mode, which is end of interrupt command mode. Now when any interrupt request it is being executed by the microprocessor and by the 8259, then the corresponding ISR bit it is set. Now this ISR bit it can be set or reset by using the automatic end of interrupt bit and also through this end of interrupt command. Now the in-service register, that is the ISR bit, it can be reset, means its value can become 0 with the AEOI, that is automatic end of interrupt bit of the initialization command word first, or the end of interrupt command which is issued before returning from the interrupt service routine. Okay, so when the microprocessor it is returning from the execution of the interrupt service routine, it can also reset the ISR bit, and also this bit can be reset by using the automatic end of interrupt bit in the initialization command word first. Okay, so there are two ways of resetting this ISR bit. Now this end of interrupt command, this can be of two types. It can either be specific or it can be a non-specific. Now this EOI command, it is used to reset the ISR bit. So our main motto in this mode, it is to reset the ISR bit. Now when the 8259 it operates in the fully nested mode, then in this mode this 8259 it can determine that which ISR bit it has to reset. Okay, now when it happens that when the 8259 does not operate in the fully nested structure and it does not know that which ISR bit it has to reset, then that in that case a non-specific end of interrupt command is issued, and that command will tell the 8259 that which ISR bit it has to reset. Okay. Now ISR bit that is masked by the interrupt mask register bit, it will not be cleared by a non-specific end of interrupt command if the 8259 it is working in the special mask mode. So in the special mask mode, the interrupt bits they are masked by the 8259. So if any of the bit it is masked, then the corresponding ISR bit it cannot be reset by using a non-specific end of interrupt command. So in the end of interrupt command mode, what it is done that the ISR bit which was set in the fully nested mode, that bit it is reset, because the microprocessor it has to know that the service routine was completely executed by it, and now the interrupt request has been acknowledged, and again the 8259 it can scan the interrupt request that which interrupt request is currently active now. Okay, so this command it is showing the end of the interrupt cycle. Okay, next we have the next mode of 8259 is automatic rotation. Now this 8259 it is known as the programmable interrupt controller, and this controller it controls the operations, like it decides the priority among the interrupt request. Okay, now how the priorities are decided: in the fully nested mode, we studied that the IR0 was assigned as the highest priority and IR7 is assigned as the lowest priority. Now if we want to change the priorities, we can use this mode, automatic rotation. In this mode, the interrupt request which is currently being executed or which is currently being accessed by the 8259, that request will be given the highest priority. Now after that any request is given, then that will be given the second priority. Okay, means like suppose currently IR4 is being executed, so IR5 will given the next highest priority, then IR6, then IR7, then IR0, IR1, IR2. Again IR4 will have the highest priority. So the interrupt request which is currently being executed, that is having the highest priority, and then when it is executed it will have the lowest priority. So that is the automatic rotation of priorities among the interrupt request. So this automatic rotation, it is used where the interrupts have equal priorities. So this automatic rotation mode, it is used where the interrupting devices which are sending the interrupt request, they are of equal priority. All the interrupting devices, they are having the equal priority. Now when they are having equal priority, so how they will be acknowledged, they will be accessed? Then interrupt request which is received receives lowest priority after it is served. So currently suppose IR4 it is served, so this is going to be when it is fully executed, fully accessed by the CPU, then IR4 will get the lowest priority, and the next device which is to be served, it will get the highest priority. And once all the devices are served, then again IR4 will get the highest priority. So in this way, the interrupt request priority, it is rotated among all the interrupting devices. Next, we have automatic end of interrupt mode. We have studied the end of interrupt command mode where the EOI command, it is generated by the CPU to the, and it is given to the 8259, so that the end of the interrupt cycle will be indicated to 8259. Now we have the automatic end of interrupt command where automatically the end of interrupt signal, it is given to 8259. So we have the fourth mode as automatic end of interrupt mode. So when the AEOI, this bit of ICW4, it is 1, that means if this bit is set in the initialization command word 4th, then this mode is active. Okay. So in this mode, the 8259 IC, it performs a non-specific end of interrupt operation at the trailing edge of the last INTA pulse automatically. So when the last pulse of the interrupt acknowledge signal given by the CPU to the 8259, it comes, then this non-specific end of interrupt command is generated automatically, and this command will show the 8259 that the service routine has been completely executed. So externally no end of interrupt command is given. If this is 1, then automatically this command will be generated when the service routine is completely executed. So this was the automatic end of interrupt mode. So let us come to the next mode of 8259, which is the specific rotation mode. Earlier we studied the automatic rotation mode in which the interrupt requests, they were having the same priorities, and then when in the order in which they are served, the priorities is decided. Now in this specific rotation mode, the bottom priority level can be selected, and this bottom priority, it decides the other priorities of the interrupt request. So in this mode, bottom priority level can be selected. How we can select it? By using the L2, L1 and L0 bits in the operational command word second, and R is equal to 1, SL is equal to 1, and EOI equals to 0. So in the operational command word second, we have the three bits R, SL, and EOI. If R is set, SL is also set, and EOI is reset, then L2, L1, and L0, these bits, they can be used to set the priority level. Okay. Now, suppose let's take an example that if the interrupt request 5, that is IR5, is selected as the bottom priority. Okay, bottom priority means that the interrupt request 5th, it is having the least priority among all the interrupt requests. So IR5 will get the least priority. Okay, and IR6 will have the highest priority. So if we see the numbers, then we have IR0, IR1, 2, 3, 4, 5, 6, and 7. We have these 8 interrupt requests. Now we have decided that IR5 has been assigned as the bottom priority. Bottom priority means that it is at the 8th number, because we have the 8th interrupt request. So this is having the least priority, means it is at number 8. Then at number 7 we will have IR4. This will be at number 6. This will be at number 5, 4, 3, 2, and 1. So IR6 will get the highest priority, IR5 will get the least priority. So this is how the priority level is decided among the interrupts using the specific rotation method. Okay, that mode is selected. So in this we decide the bottom priority, and according to the bottom priority, the priorities of other interrupt requests will be fixed. Now next mode we have is the special mask mode. Now in the operational command word first, we have the 8 bits, and those 8 bits decides the mask bits of the 8 interrupt request. Okay, so for IR0 we have IM0, for IR1 we have IM1. So for every interrupt request we have a mask bit in the operational command word first, that is OCW1. So when a mask bit is set in OCW1, that is operational command word first, it inhibits further interrupts at that level. Okay, so for every interrupt request we have a mask bit. Like for IR0 we have M0. For this we have M1, M2, M3 till we have M7. So these 8 bits of the operational command was 1. If any of the bit is set, so that corresponding interrupt request will be inhibited, and all the other requests, they will be executed, they will be enabled. Okay, so this, in this special mask mode, we can mask or unmask any of the interrupt request. Okay, next we have the edge and the level triggered mode. Now the interrupt requests, they can be either edge triggered or they can be level triggered. And this edge and level triggering, it is decided by the bits in the we have the initialization command word first. Okay, so we have if the bit LTIM in ICW1 is equals to 0, then it is edge triggered. And if LTIM is 1, then it is level triggered. So this triggering is decided by the LTIM bit in the initialization command word first. Okay. So this mode, what this mode is deciding that the interrupt is either edge triggered or level triggered. Then next we have the 8th mode, which is reading 8259 status. Now to read the status of the 8259 IC, we have the status registers. There are 3 status registers. One is the in-service register. Second is the interrupt request register. And third is interrupt mask register. These 3 registers, they are combinedly known as the status registers of 8259. This is ISR, this is IRR, and this is IMR. So in service register, it stores the information about the interrupt which is currently being executed. Then interrupt request register, it gives us information about that which interrupt request has been generated. And interrupt mask register, it gives us information about the status of the interrupt requests which are masked and which are unmasked. So these 3 registers, they can be read using this reading 8259 status mode. Okay, now how these registers they can be read? We have the operational command word 3. Okay, in this operational command word 3, we have the bits to read the IRR and ISR register. While we have the operational command word first, which is OCW1, which is used to read the bits of the interrupt mask register. So these 3 registers, they can be read by using the operational command words third and operational command word first. So the status can be read by using this mode. Now this reading of the 8259, it is possible only when the 8259 it is working in the no hold mode. If it is in the hold mode, then this reading is not possible. So let us come to the next mode of 8259, which is the hold command mode. Now, whenever the 8259 IC it gets the interrupt request, so in corresponding to that interrupt request, the 8259 it generates the interrupt output signal, and this signal is given to the microprocessor so that it can be interrupted. Now, in the hold command mode, in this mode, the int output, the interrupt output pin, it is neglected. Okay, means this input output mode, this interrupt output signal, it is masked by the microprocessor. Okay, so in this mode, the INT output of the 8259, it is neglected by masking the INT input of the microprocessor. So this INT output of 8259, it is connected to the interrupt input pin of the microprocessor. So by masking that input pin, the this poll command mode can be executed. Now in this mode, it is selected by setting the P in operational command word third. This P, it is a bit in the operational command word 3, and when this bit is set, then the 8259, it works in the whole command mode. Okay, so this interrupt output pin, if it is negligible, then how the microprocessor, it is going to know that the interrupt request has been generated? So this control word, it is given to on the data bus, and through the data bus, the microprocessor will get to know that which interrupt request has been generated. So W0 to W2, it is the binary code of the highest priority level which is requesting the service. Suppose like IR3 is being generated. So for IR3, we have the request signal like 000, 001, 010, and 011. So for IR3, we have 011. So this code will be given here 011. Okay, so through this command word, through this control word, the microprocessor will get to know that IR3 interrupt request has been generated, and when this I, which is D7, it is equal to 1 if there is an interrupt. Okay, so this is the priority level of the request which is requesting the service, means IR3. Its binary code will be given here, and if it is 1, then means that an interrupt has been generated. So in this poll command mode, the INT output of 8259, it has been neglected, and through the control word, the microprocessor is getting to know that as an interrupt request has been generated. Now next we have the special fully nested mode. So this special fully nested mode, it is used where the cascading is used. Cascading means that where more than one 8259 IC is used. So when more than one is used, then one 8259 IC will act as the master IC, and the other ICs, they will act as the slave 8259. Now the priority has to be programmed in the master 8259 IC using the ICW4. This initialization command word fourth, it is used to decide the priority among the interrupt request of the master 8259 IC, because various slave ICs are connected to it. Now which slave IC has the highest priority, which is having the lowest priority, that is to be decided for the master IC. Okay, so this master IC initialization command word, we can use the initialization command word fourth to decide the priorities. Okay, now in this mode, when an interrupt request from a certain slave is in service, means like there are various slave which are connected to the master IC. Now if any slave has given a request and that request is in service, this slave can further send requests to the master. Okay, so it is not possible that once it has given a request, it cannot give any other request also. It can also generate other interrupt request. Okay, now once like in the fully nested mode, we have studied that if one request is being accessed by the 8259, then all the other requests which are having priority lesser than it, they will be masked, but it is not there in the special fully nested mode. So in this special fully nested mode, the slaves, they can request one or more interrupt requests to the master IC. Okay. Now when the 8259 it is executing, the master IC, it is executing any slave request. So the end of interrupt command will be issued saying that ISR, interrupt service routine, has been completely executed. Now when this EOI command, the end of interrupt command, is given by the master IC, it is received by the master IC, then this master 8259 will get to know that interrupt cycle has been end. Now at that time, that 8259 IC will check that whether the end of interrupt command has been set to 0 or not. Okay, if it is not set to 0, it means that the slave has given another request also. Okay, so it will then execute the second interrupt request, and then again it is going to check that the EOI command, it is whether 0 or not. If it is 0, then it is going to check the interrupt requests which are generated by other slaves. So using this special fully nested mode, it is possible that the slave can send one or more requests to the 8259 master IC. Okay. So every time whenever the interrupt service routine is being started execution by the microprocessor, the software has to check that whether this is the only request from the slave or not. If any other request is also there from the slave, then that request will also be executed. Now next we have the buffered mode. Now in 8259 we have the 8-bit bidirectional data bus, and this data bus has data buffers, and these data buffers has to be enabled for the transfer of data between the microprocessor and the 8259. So these buffers, they can be enabled or disabled using the buffered mode. So these data buffers, they can be enabled or disabled using the buffered mode. And how this enabling and disabling is done, we have this SP and EN signal, or this pin is available on the 8259 IC, and when this pin it is equal to 1, then it means that the data is placed on the data bus. Okay, so the enabling and disabling of buffers, they are done using this pin, so that the data which is can be placed on the data bus, the transfer of data can take place. Next we have the cascade mode. This mode is used when number of 8259 ICs, they are interacting with each other. So in this we have the 9 8259 ICs, and in these we have one master IC and 8 slave ICs. So one master can have 8 slaves, okay, and these 8 slaves can take 8 interrupt requests. So in total we have 64 interrupt requests. So for these 64 interrupt requests, the 64 priority levels have to be decided. Okay. Now we have 3 lines, CAS not to CAS 2 of the 8259 IC. These lines are known as the cascade lines, and these lines act as the chip select lines for the slave ICs. Suppose we have a master IC, okay, and to this master 8 slaves are connected. Okay, now how this master is going to identify that which of the slave it is connected to it? So these identification, it is done by using the cascade lines. So these 3 lines can have combination 000, 001 till 111. So 000 it is for slave 0, then 001 it is for slave 1, and 111 it will be for the slave number 7. So in this way the master can identify the slaves using these 3 lines. Okay, now this is for the master IC. Now how these lines for the slave ICs, what will be there? Okay, so these cascade lines for the slave 0 to slave 7, they are used to select the interrupt request. Okay, that is IR not IR 7. So this slave will also have 8 interrupt requests, this will also have 8 interrupt requests, and this will also have 8 interrupt requests. That is from IR not to IR 7. Now, when any of the slave will receive an interrupt request, it will generate an INT signal. Okay, this interrupt output will be connected to this master will also have the interrupt request signals IR not to IR 7. So when this slave 7 has generated an interrupt request, this will be given to the IR 7, and then this master is going to generate the INT signal which is given to the microprocessor. So here I have written that the slave INT outputs, they are connected with the master IR inputs. So INT output of the slave is connected to the IR input of the master. Okay. Now when this master slave this master IC, it has given the interrupt signal to the microprocessor. So microprocessor, it is going to generate the interrupt acknowledge signal. Now when this interrupt acknowledge signal it is received by the master, then the slave is going to send the vector address where the service routine is written, and that vector address will be available on the data bus, and then the master is going to receive the vector address, then master will send that vector address to the microprocessor, and then microprocessor will execute the service routine. So in this way the interrupt request in the cascade mode, they are executed, they are accessed by the microprocessor. Slave will first send the request to the master, and then master is going to interrupt the microprocessor. So in this mode, we have the various 8259 ICs which are working as the slave or as a master. Okay, now these 8259 ICs, because they have to be initialized and they can be programmed in different modes. Okay, so separately they have to be initialized. Okay, because all are 8259 IC, so using the initialization command words, all the ICs have to be initialized independently, and also the various modes of operation for each of the IC has to be separately given. Okay, now we have the end of interrupt command also. So after the execution of the interrupt service routine, end of interrupt command was given to the master IC also, and for the slave IC also. So two EOI commands they should be generated, for one for the master and one for the slave. Okay, so this was the cascade mode of operation of 8259 IC. So in this video, we studied about the various modes of operation of the programmable interrupt controller. First, we studied there were 12 modes of operation. First was the fully nested mode. Then we studied the end of interrupt mode and automatic end of interrupt mode. Then we studied automatic rotation, specific rotation was there. Then we have special mask mode there. Special fully nested mode is also there, and edge and level triggered mode, pole command mode, buffered mode, cascade mode. Okay, so there were the 12 various modes of operation of 8259, and these modes can be set or reset by using the initialization command words and the operational command words of 8259. Okay, so I hope that this topic is clear to you. Thank you.